Good afternoon. Welcome. Today we're going to be looking at factoring special products. Recall that in the previous section we were multiplying special binomials. This time we're going to be factoring, which is just kind of going back in reverse. We're going to look at two of them, the difference of two patterns, and then the special perfect square trinomial pattern. Let's start with the difference of squares. Here recall that in this previous section we multiplied binomials of this form. And we ended up over here. This is a special type of a situation we call the difference of two squares pattern. And just to verify that we can go from here to here, I'm going to multiply this for you just by using distributive property. We'll multiply this times that, which ends up giving us a squared minus ab. And then we'll multiply this to that. This ends up giving us plus ab minus b squared. Notice how we have a zero pair here in the middle that just crosses out. So in fact we have a squared to b squared left, and it should look familiar like that. So this is a special situation we have, which is a difference of two squares pattern, and we're going to be using it to factor binomials that are in this form. We have example number one here, and I just want you to pay attention to this. So we started with x squared minus 9. Is this a difference of two squares? Well, of course it is, because when you look at x, it's squared. We're subtracting, of course. 9 is a perfect square number. In fact, we can rewrite 9 so that we show, in fact, that it's a square term. So rewriting 9 into a square term, we're going to end up with x squared minus 3 to the second power. So at this point, it allows you to see that this is, in fact, a perfect square, and it's in this form. Once that's the case, we can use the the difference of two squares pattern to factor it, where we just take the x here and the x over there, 3 here, and we're going to add and subtract in all of them, and then you're done at that point. Let's take a look at another example. X squared minus 25. Well, this is also a difference of square pattern. This is a perfect square term, it's squared. 25 is also a perfect square term. In fact, we're going to rewrite it in this form to verify. So we have x squared minus 5 squared. Once we rewrite in this form, then we can use the difference of square pattern and then factor it completely by writing x here, x over here, and then we're going to add and subtract in the other one. Okay. Now we're going to take a look. All right, recall here, now we're looking at perfect square trinomial pattern. And I want you to recall here that in the previous section, we used to start with this. We multiplied or expanded this to get to here. For example, what we did was we just went on ahead and squared a, and then b squared. And in the middle, we multiplied 2 times a times b to end up with that. That's one of the perfect square trinomial pattern. The next one, if we had something like this, we just went ahead and squared a, we squared b, and in the middle we multiplied 2 times a times negative b to end up with that. This is the two patterns that we're going to be using for the perfect square trinomial. Let's take a look at some examples. All right, for our first example, it's very important again for us to remember that if this is a perfect square trinomial, then we can write it in the form a squared plus 2ab plus b squared. So let's go ahead and try and see if we can write in that form. N squared will stay as it is, plus, remember I have to have 2 times the variable, and then what's the other number that I need to have over here? 4. So that 2 times 4 will give me 8, and then n is there. 16 will turn into 4 squared. And yes, this turns out to be a perfect square trinomial, as we can rewrite it in this pattern. So when that's the case, in order to factor this, we're just going to write n, and then our b is 4. We're adding everything, so we're just going to do that, and then we're done. For our next problem, we're going to do the same thing over here, where can we write this in the form a squared minus 2ab plus b squared? The answer is yes, we can write this as 2x squared minus 2 times x times 6 plus 3 squared. Therefore, this is just going to be 2x minus in here 3, and then we square it. Why? Because we were able to write it